the vertex form of quadratic functions. So let's say you're given a quadratic function such as f of x equals x minus 2 squared plus 3. Well, this function is in vertex form, and vertex form is the following: x minus h squared plus k, where h and k equal your vertex. Okay, so you can see also that this function right here, it's a shift to the right by 2 and a vertical shift up by 3 of our normal quadratic, our basic quadratic function, y equals x squared. Okay, we can also find the zeros of this function by doing the following. By setting, by setting x minus 2 squared plus 3 equal to 0. And then we move that negative 3 over to the other side, and then we take the square root of both sides. And you'll see, when we take the square root of a negative number, we're going to end up with an imaginary number. So here's what happens. We get x minus 2, the absolute value of the square root of 3i, and then that equals x minus 2 equals plus or minus the square root 3i. So then x equals 2 plus or minus the square root of 3i. Now, we can also change the vertex form to the ABC form of a quadratic function. So let's say we have our example again, where x minus 2 squared plus 3 is our function. Well, we can change this to a, b's, and c's by then expanding x minus 2 squared, and that becomes x squared minus 4x plus 4, and this 3 comes down also. So you'll see that x minus 2 squared, you get the b term, this middle term, by doing multiplying negative 2 times x and then multiplying by 2 again to get negative 4. And this 4 comes from negative 2 squared. Okay, so we can simplify this further, in particular these constant terms. So it becomes x squared minus 4x plus 7. Okay, and we can use the quadratic formula to find zeros here, and it should be the same answer we got before, which was 2 plus or minus the square root of 3i. So here's the quadratic formula. X equals the opposite of b, which would be 4, plus or minus the square root of b squared, which is 16, minus 4 times a, which is 1, times c, 7. Okay, over 2a. And a is just 1, so we get 2. Okay, so you can actually see that in the discriminant, which is b squared minus 4ac, we're going to get a negative number, because this negative 4 times 7, that'll be negative 28, and that's a greater, negative 28 is greater than 16, so we'll end up with a negative number, a negative 12. So let's rewrite this. X equals 4 plus or minus the square root of negative 12 over 2, and that's over 2. Okay, so x equals 2 plus or minus, so negative 12, we can pull out the negative square root of negative 1, get an I, and that 12 then breaks down to the square root of 4 and the square root of 3. That's all over 2. And the square root of 4 is just 2, so these 2's will cancel out. And you get 2 plus or minus the square root of 3i, which is what we wanted before. And that's the 0, or x-intercept, of our original function.